Okay, starting section 3.1. Oh my God, this is going to look kind of choppy, but that's okay. The first theorem talks about planes, and I needed to try to get some pretty planes, and this is about as good as I could come up with on the short time that I got. So, the theorem says that when you have two planes that are parallel, and we can see that this bottom one and this top one is parallel, that if there is another plane, like this one, that cuts them or intersects both of them, that's what cut means in geometry, that intersects both of them, then the two lines that are formed by that intersection are going to be parallel. And we can see that that's true. If you can visualize it, it helps. So since we can see that this top line right here where it intersects our top plane and our side plane, and this bottom line right here where it intersects our side plane and our bottom plane are actually two lines that are parallel. That's all it says. No need to confuse, honestly. Now I can put that down for a bit because it's hurting my hands. Nice. Okay, so to review, because I told you I use symbols a lot. The double lines mean parallel. Those are parallel lines, or parallel planes, or parallel whatever it is we're talking about. And the perpendicular is the upside down T. Sorry, reminded of something from my past. The perpendicular is the upside down T, and I'll refer to that when I'm talking about perpendicular planes or lines or whatever it is that we're talking about at the time. Now, all of that to be said to draw this really pretty picture. Just like magic. I like how that stuff works. Okay, so when we have two lines, incidentally, they have to be coplanar, but generally speaking, they are. I mean, they are in the plane of the book, if nothing else. When we have two lines that are cut, they use this word cut. If they don't use it, I use it because it's traditionally what we call it. Cut by a transversal, it forms many different angle pairs. So here I have two lines. There's nothing that says that these are parallel, even though they kind of look like they might be. We have no proof that they are, and that's fine, good, and wonderful. It doesn't mean anything. But they do create angle pairs, whether they're parallel or not. They are being cut by a transversal. In this case, A is our transversal, and being cut just means it slices right through them. That's all. Goes through both of them. So, since our two lines, which are B and C, are being cut by transversal A, and you have to know which one's the transversal and which one's not. So here's the definition of a transversal. It's got to go through two lines in order to be a transversal. It can't just go through one. So we can't call B a transversal because it only goes through one line. We can't call C a transversal because it only goes through one line. So it must be A that's our transversal. So when we have two lines that are cut by transversal, we get a whole myriad of different kinds of angles. And just because one angle falls into one particular type doesn't mean it's not going to be another particular type, because we reuse these angles because it's angle pairs. They have similar qualities, and so we group them together by their qualities. So let's talk about them. First of all, you have a whole myriad of linear pairs. You already know what that is. It's black underline. And it should be, because it's in yellow, part of your definitions already. So I gave a definition of what linear pairs are. So if I wanted to list out these linear pairs, either color for it, we can start with angle 1 and angle 2. They are a linear pair. I know that because they share a common line and they are adjacent to each other. And working around, we can get angle 2 and angle 4, linear pair. Angle 3 and angle 4, linear pair. Angle 1 and angle 3, linear pairs. That's 4 of them. I bet you can get the other 4 too. They would be the ones that are down here. So I went all around up here, and you can go all around down here. You're going to get 8 different sets of linear pairs. Now, you might be looking at the list and thinking, wait a minute, vertical angles are not on that list. That's true. I didn't put vertical angles on the list because I know you already know them. But there are facts about vertical angles that work no matter what kind of situation it is. And since we know you know about vertical angles already, I didn't throw them up on the list. I was just reminding you about linear pairs and the rules for linear pairs. We'll get to that in a minute. Just hold your horses. In addition to that, we have something called interior angles. Interior angles have to be inside the 2 lines. They're the ones that are inside. You don't get any fancy rule about them being supplementary or anything. All we know is that they are inside. They lie inside the 2 lines. So in this particular case, our interior angles are going to be angles 3, angle 4, angle 5, and angle 6. I know that because they are in between these 2 lines. They're the only angles that we have that are in between these 2 lines. Can't go outside the lines. Once you go outside the lines, that makes them exterior angles. So our exterior angles are going to be the ones that fall outside of those 2 lines. That's angle 1, angle 2, angle 7, and angle 8. And then we have something called corresponding angles. Corresponding angles correspond, which basically means they hold the same position on a different intersection. So let's talk about this one because I got to make sure you get this one right. Corresponding angles have to hold the same position on a different intersection. So I've got 2 intersections. I've got this one up here and this one down here. So angle 1 holds the same position as angle 5. We don't know that they're the same. We don't know that they're not. We don't know anything about them except they are in the same general position. It's to the left and up. So angle 1 is to the left of our transversal and above line B. Angle C is to the left of our transversal and above line C. Sorry, angle 5. So that means that angle 1 and angle 5 are going to be corresponding angles. Come up with another set of corresponding angles. Go ahead. Throw them at me. I can hear you. I promise you. I got this. Go ahead. I know you don't want to talk. You want to try this and see whether or not it works. But I promise you, I know what you're going to say. Go ahead. Go ahead. Angle 3 and angle 7. Hold on. I'm not writing that fast. Just chill out a minute. Give me a break. Angle 3 and angle 7. And then I heard angle 2 and angle 6, which leaves us with angle 4 and angle 8. See, I told you I knew what you were saying. Just that simple. Can't write them as fast as you can say them, but they're there. Okay, So we talked about interior angles and exterior angles. You know, interior angles are in between the two lines, right? And exterior angles are outside the two lines. That leaves us with alternate interior angles that we need to talk about and alternate exterior angles that we need to talk about. So for alternate interior angles, they not only have to fall inside the two lines, because that's what makes them interior. So I'm just going to write that they're interior angles. But they are on opposite sides of the transversal. What? So if I had angle 3, it's an interior angle because it's in between the two lines. If I had angle 3, I have to find another angle on the opposite side of the transversal that is interior as well, and it can't form a linear pair. I didn't say that part, but it's understood it's not going to form a linear pair. So that would mean that it would be 6, because 3 is opposite from 6. You want the one on the other intersection. So angle 3 and angle 6. And then the other pair of alternate interior angles is angle 4 and angle 5. That's the common one. And angle 5. Alternate exterior angles obviously are exterior angles, which means they're outside of the two lines and on opposite sides of the transversal and can't be a linear pair. For these two, no linear pairs allowed. So I know you were saying it. Hold on. I'm writing here. Give me a little bit of time. You know, you have to write all this down too. I don't know why you think you can just sit there and watch. Okay, so angle, you said 1 and 8. And then angle 2 and angle 7. I can make it work. Okay, so once again, doesn't matter what our lines look like. I could redraw my C. And as long as A cuts C or intersects with it, we know we're good. So my C could actually, instead of being up here, look like this. That could be C. And technically, instead of B looking like that, B could look like this. Ooh, this might be harder to solve. So it could be a triangle that we get. And even if it is a triangle, we still have these angle pairs here. Because what happens out here doesn't matter. What matters is that we have two lines, doesn't matter if they intersect or not, we have two lines that are being cut by a transversal. That's all that matters, and we end up with all of those angle pairs. Now, turn page. That leads me to a problem. Well, actually, it leads you to a problem. And here it is. This is what will effectively be your classwork for this section. So you need to go ahead, write this down, and decide whether these different things are a linear pair, corresponding angles, alternate interior angles, alternate exterior angles, or vertical angles. Those are your only choice. If you find out it's something else, we may have to discuss it. So you need to pause the tape now, because when I come back, I'm going to give you the answers to these and you'll know whether or not you did them correctly. Okay, hold that thought. I'm not sure why I bothered pausing the tape. You're supposed to be the one pausing the tape. I'm supposed to be the one giving the answers. Are you ready? I'm going to give you one more second. Okay, so what was your second? Angle 7 and angle 1. Angle 7 is down here. Angle 1 is there. They are clearly vertical angles. Notice I abbreviate anytime I get a chance. Angle 2 and angle 5. Angle 2 is up here. Angle 5 is down here. Those are alternate exterior angles. Alternate exterior angles. Angle 6 and angle 4. Angle 6 is up here. Angle 4 is down there. Alternate interior angles because they're in between the two. Angle 6 and angle 8. Same side. One's interior, one's exterior. So that must make them a linear pair because they can't be anything else. Angle 3 and angle 8. Angle 3 is here, angle 8 is there. They're vertical, straight up vertical angles. Angle 6 and angle 5. Angle 6 is up here, angle 5 is down there. Not alternate anything. Corresponding angles. Okay. Number 7 is angle 7 and angle 3, once again corresponding. Told you, I abbreviate when I can. Number 8 is angle 2 and angle 4, 2 and 4 corresponding. You know, we switch these numbers around all the time, right? So you can't just memorize that angle 2 and angle 4 are always going to be corresponding. Angle 3 and angle 1, alternate sides of the transversal, both interior, makes them alternate interior angles. And then angle 1 and angle 8, they're corresponding. And then angle 8 and angle 7, ooh, that's new. Alternate exterior. Oh no, we had to have one of those. Alternate exterior angles. And then angle 1 and angle 3, alternate interior. I'm guessing you did pretty well on that. It didn't seem to be too terribly difficult. All brand new information, but you can pretty much handle it. Now, your homework, on the other hand, does not come from your book. Isn't that good to know? Your book started doing some weird stuff, so I'm trying to grab your homework from other places when I can. So your homework is actually the workbook page, number 44. I scanned it. I sent it to your mom. She has it. It is the workbook page. Number 44 for your homework. Yes, you have to do all of it. How horrible of a person am I? And you'll see me tomorrow.